close that.
Yep.
And then where is my script?
Probably just need to open it again.
Again?
Mm-hmm.
Oh, yeah, you're right.
So open recent. And then,
It doesn't matter.
well, I only fixed one of them. So whichever one.
Oh, let's assume it was this one. Okay.
So if you're ready, we can start screen capture.
Okay, that should be good. Okay, thanks for your help. Oh, and wait, let me just Command Tab. Can I close this?
Yep.
Command Tab. How do you get to PowerPoint?
Command tab, and then,
Oh, I just keep hitting Tab.
Yep.
And then it'll go there.
yep. And you can do that while you're in the PowerPoint.
Okay, perfect.
So
Thank you.
I'm going to start the screen capture. So
Do we have that going? Camera's on? All right, sweet. Thank you, Neil.
Sorry.
Okay, hi everybody, thanks for coming. Sorry for the delay, I'm not used to Mac, so my computer wouldn't hook up to the projector, so I was getting a quick tutorial on setting this up for Macs. So I'm glad you guys were able to come, and my name is Sarah Burke. I'm a PhD student in the Industrial Engineering Department, and I'm the Vice President of the Graduate Statistics Club. And so this is just an introductory session on using R software. So coming in with the assumption that you've never used R before, so this will be a nice little startup for you, and our hope is that in the future we can do some more advanced topics now that we have these basics out of the way. Okay, so let's go ahead and get started. So I'm just going to do quick background on R, the basic setup, give you all some help resources, and then the meat of it is going to be in the different data structures in R and how to work with them, and then follow up with some basic statistics, you know, t-test, doing linear models, that kind of thing, and then if we have time, just to show you some introductory graphs depending on time. Okay. So background, so R is a language and environment. It's for statistical software and computing. It's free and open source software, so it's constantly changing. Any user in R can add new code and new packages, they call it, to change the code as you develop new statistical tests. And it's command line driven, so different from jump or Minitab, right? So you have to enter in the command lines as you go. Okay, so these are what I consider some of the advantages and disadvantages. You might think of others, but obviously an advantage, it's free. The graphics actually have really high capability, especially for publications. So there is a lot of ways you can adjust graphics to make them very high quality. The ability to extend functionality, and you can also link in other programming languages into the software to run additional code if you already have that written. So some of the disadvantages, well, the reason we're here, right? It's a little bit hard to learn how to use, the ease of use, the syntax. It is case sensitive, maybe not a disadvantage, but just a mistake I tend to forget about sometimes. Because it's open source software, the help documentation depends on the function or the package you're using. So sometimes you get help documentation that's really good, and sometimes you get some that's not so great. So that can be one disadvantage. And for me, I find that pre-processing data can sometimes be a little tricky in R, but once you get a handle on the software, it tends to be a little bit easier. So if it's a little bit messy data, it needs a lot of pre-processing work, sometimes that can be a bit of a challenge in R, but it is doable. Okay, so downloading R, everything's at the R Project website. It's available for Macs, Windows. If you have questions about the different operating systems, I'm a Windows person, so that's going to be my more expertise than dealing with the other ones. So you select what they call a comprehensive R archive network. Usually you just pick the one that's closest to you. So there's one in California. And select the appropriate links and everything like that. And it comes with a basic R package, a base directory. Okay, now I sort of mentioned packages. So what comes in the base directory when you download R, it includes a couple of what they call packages. So it includes base, the basic statistical tests, utilities, some basic graphics, some built-in data sets, and some methods. This is all standard stuff with the operating language and how it all runs. Okay, but like I said, the functionality of R can be extended to add-on packages. So users can write their own code to do other different types of statistical tests or methods, and they can be very specific. So there's some, for example, for additional graphing capabilities. There's some for data mining techniques, nonlinear regression. There's hundreds and hundreds of packages that you can install and load onto your computer to be able to do that analysis. Okay, now to be able to use this, and I'll do a quick example of how to do this later on once we get into the software, of how to install a package into your system and then load it. And just one thing to keep in mind is to use a package, you have to load it into your session before you can call a function to be able to run it. And I'll do an example of that later on. Okay, so I'm just going to get into the basic setup of R. So here is the R software. When you first open it up, this is the console window. It always starts off with this little opening message. And so you can enter in code directly in here. This cursor, let me pull this over actually. You can see it a little bit better. This cursor right here is saying that it's ready for input. Okay? And so that's where you can enter in your data, and this is where the output of your analysis is displayed as well. Okay? You can also have what they call a script window. And I tend to work in the script window a lot more because you can save your code and use it for when you're rerunning it. So if you're doing the same analysis over and over again, you can type the code in the script window and then just run it all in one block of code. So that saves extra work later on, so you don't have to type the same things over and over again. Okay, and you can add comments as well. Okay, so this is for Windows, this picture. So in the top part, that's what the script window looks like in a Windows setup. And there is a button highlighted in red where you highlight the text that you want, you click that button, and it automatically runs it in the console window in R. In Mac, it's a little bit different, as I've discovered. And so when you go in to run it, so here I just have a quick vector. So if you hit the command and then enter, and it pulls it up into the console window here. Okay, so it also runs the similar way. So I just entered the block of code and it pulls it right into the console window. Okay, so I like to work with that more. Okay. There's also a graphics window that gets pulled up whenever you create a graph, so it's not there by default. So once you enter in a command to make a plot, this window will pop up and it'll show your plot. So this was just a simple scatter plot just to show the window pops up once you type in the code for it. Okay, so those are the basic Windows in R, pretty simple setup. Okay, so before that, I just wanted to let y'all know about a couple of help resources, just if you need help with a function name. So there are some built-in ones where it'll send you to the help file. So for example, say you want to make a box plot and there is a function for that, you can just do help and enter in the box plot, and it pulls up the R help documentation for that function. So this gives you the default arguments, the different possible arguments you can put into the function, and it also comes with all the details. And at the very end, it also usually gives some examples too with some sample code. Okay, so you can use that if you need additional help. Okay. If you don't know the name of the function, but you have an idea of what you want to do, like say, I want to do like a normality test on some data, you can just put in 2 question marks and spell normality correctly, and hit enter, and it'll pull up a package or some help resources of where you can find tests on how to do things like that. Okay, and it'll give you some additional information here. Okay. Okay, there's also some other functions that you can get, or some functions you can use. So this args and then the function name just gives you the different arguments available for the function, so if you want to be able to look that up quickly. And what also is pretty nice is the example. Not all of these functions have that, but some do, and they can be really nice. So let's do the example on boxplot again. Okay, so I just have example, and then the function name is boxplot. I hit enter, and it will pull up a window. Okay, so this is the graphics window, and here it's starting down here to display some of the examples. This is with built-in data sets. So if I click enter in here, it's going to pull up, or in here it's return. Sorry, it's a little different than in Windows. So here if you hit return or hit enter on a Windows machine, it pulls up the code and then it shows you what the plot looks like in the graphics window. And it has a couple of these that you can do and see different examples of box plots. Okay, so that's pretty nice if you're just trying to learn out some new functions, and it'll give you examples built in. Okay, so let me just finish this out. Okay, and that's the end. It had a couple examples. Okay. Okay, and then here are some other resources not built into the R software itself, but I found fairly useful. There's an R manual that you can look up. I found this online. It's a PDF. It's about a two-page thing, a two-page reference that just has a bunch of the key functions that are really useful if you want to just wait a minute. How do I, call that linear models function again? This is a nice, quick little reference card there. This is also a website, Cookbook for R, which actually you can access the reference card from this website. They have a link for it on there. And so this has some nice little how-to, do a couple of different things. There's a website, R Bloggers, which has user-contributed blogs on applications of R. This book here, R Cookbook, I actually used to help get these slides together. It was a nice, useful resource on that. And then there's some books for graphics. And then this link here, and I can send out these slides if y'all would like them afterwards, just let me know. And this has all of the different arguments and parameters when you want to graph. So how do you change different symbols, or you want a different line style. So that's really nice too, so you don't have to memorize, the number 1 represents a filled circle or things like that. So that's pretty useful. Okay, so with that, I'm just going to start diving into actually doing some coding in R. Okay, so basics, we're going to start with just entering some basic values. Okay, so if you want to assign a variable, a value to a certain variable, you just enter in whatever variable name you like. It needs to start with a letter. It can't start with a number or a character sign. So say I just want to say x equals the value 2. Okay, so I can just do that. Now automatically it doesn't print what that value is stored and what the variable is stored as. So if you want to see it, you just enter in that variable name again, x equals, and it's saying, okay, now it's equal to the value 2. Okay, there is some protected variables. So say you want pi, so I'll enter in y equals 2 times pi. That's a protected value. Okay, and there's y, and it gives us 2 times the value of pi. Okay. So that's just basic entering in data. Okay. And I have a couple of useful functions that I find to be a little bit, useful for me when I'm doing some analysis. One is this ls function. Now what this does, it tells me what variables are currently defined in my session right now. Okay, so I already defined a couple, this a and the x and y. You saw me just do that. The other ones were from those box plot examples. They define variables. So if I want to say, if I just can't remember which variables I have defined, I have a list of which ones they are, and I can call them again. Now say I want to get rid of one of them, I can use this rm function, remove, and say I don't want that mat function there anymore. Okay, so that's going to remove it. If I look up what variables I have now, it's now gone. Okay, so that can be useful. Okay. One other useful function I found is this search function, which lists what packages are currently loaded onto the session right now. Okay, so these are all the ones that come in the base directory of SAS when you download it. If you install additional packages, for example, there's one called ggplot, which is for more advanced plotting, that would show up on here as well. So you can see what packages are available for you. So now I'm going to talk about the different data structures in R. If there are any questions, feel free to interrupt, okay? Or if I need to slow down, okay? So just let me know. So basic data structures in R, we have vectors, factors, matrices, lists, and data frames. These are just the key ones, so I'll just go through them one by one. Okay, starting off with a vector. A vector is a basic data structure. All of the elements need to have the same data type. So data type, it could be numeric, it could be string, a character, Boolean values, etc. And one thing to keep in mind, there are indexed by position, and the indexing starts at 1 and not 0, which is different than a lot of other software, programming languages. Okay, the indexing does start at 1. Okay, so let's just enter a couple different vectors here. Okay, so here I have the code already written out just to save some trouble and try to avoid mistakes. So here, the basic structure is you assign it to a variable name if you like, you don't have to. And then you use this C function, I think it stands for concatenate, and you just list the elements individually separated by commas. So here I have just an example of a numeric vector. Okay, and in my console window, it's listed here. A is the values 1 through 5. Okay, If you want to see it directly, so it automatically doesn't print the variables once you define it, but if you enclose that expression within parentheses, it will print it. So here I've assigned this vector b, and I want to print it automatically. So I enter it in, and there is my new vector. All right, those values 5 to 25. Okay, you can do some basic addition, vector notation. Okay, it does the arithmetic element by element. Okay, so it's adding a plus b, just like that. Okay, now let me just scroll down. Okay, here are some of the other examples with non-numeric data. So here I said, hooray, statistics. Okay, so if you want it to be a character vector, the values need to be enclosed by quotation marks. Okay, and these Boolean values need to be capitalized for them to be recognized as a Boolean true or false value. If you put them in lowercase, it'll convert it to a string or a character. Okay, so those are just basic entering those. Okay, if you want to have e raised to some power, that's just the function exp. Okay, so there's e to the power of 1. Okay. So that's basic entering in vectors. Now, sometimes you want to create, a large sequence of numbers. So here's a couple of useful functions just for that using sequence. Okay, so say I just want the numbers 1 through 5. Well, you can enter in them individually, or you can use the sequence function. Okay, so that's A, and you just have SEQ, stands for sequence, and it'll start with the first number and go by 1 to up to the top one using the colon function, using this colon notation. Okay, alternatively, you can specify it like this, starting from equals 1 all the way, and then comma 2 equals to 10, or whatever value you like. Okay, or if you want to go in descending order, you can start from 5, for example, and then to 1. So there's A, numbers up 1 through 10, or B, 5 down to 1. Okay, so just some useful things like that. If you don't want to go by ones, say you want to go by some different value, you can add in this extra argument by and have it go by some other value. So 2, 0.5, whatever you like. So there's an example of this one. Okay, and that returns the vector 1, 3, 5, 7, and 9.
Is there an easy way to do a geometric sequence?
There probably is. There'd probably just be another argument or another function name for that. I don't know offhand, but we could find out, absolutely. Yeah, good question. You may also want to repeat values. Repeated values are common as well. So say I just want to repeat the value 1 10 times. You can use this function repeat, R-E-P. Okay, the first argument is just the value that you want to repeat. Now it could be one single value, or you could have other expressions that you want repeated. And the values you want repeated don't have to be numbers. They can be Boolean, they can be string, whatever you want. Okay, so here I just say I want the number 1 10 times. Okay, here's my vector, and I have that there. Now this number here is just representing the index of the vector. Okay, so it's just saying this first value starts at the first indexing position. In this example, I have true or false. Okay, I want to repeat true or false. And what this each argument does is it's going to repeat the first element 5 times and then the next element 5 times. So rather than doing true, false 5 times, we get it element by element. Okay, so it returns this function, or this vector. Okay, now say you want to reference an element in your vector. So here I have just a simple little string vector here. Okay, statistics is awesome. And if you want to reference a certain element in your vector, you just use this bracket notation, and in the middle you can put the index, or you can also use Boolean values, which I'll show in a little bit. So say I just want to return the first element in my vector. I do A bracket 1, and it returns statistics, returns the element. Okay. Now say I create a vector that has different data types. It's going to convert everything to a string, okay, because they all have to be the same data type. Okay, so note the quotations around all the different values. It's converted everything to a string. Okay.
What does the pound sign do?
Oh, good question. The pound sign is for comments. Yeah, so if you want to add comments into your code, just put a pound sign in front of it, and so it won't read this portion of the code inside the R console. Good question. Okay, if you want to reference more than one element at a time, you can use our vector notation again, and it will pull in those values. So say I want the first and third elements, right? I can use my bracket notation in the vector, and inside the brackets, I have the values 1 and 3. So it's going to pull the first and third elements in my vector. Okay, so in here I have statistics, awesome. Okay, so pretty simple. You can also use the sequence notation 1 through 3, okay, and it'll pull everything, or the first through third elements. In this one, it only has 3 elements to begin with. Okay. All right, you may find that you also want to know how many elements are in your vector, and that function is just length. And in parentheses, you put the name of your variable, or the name of the vector. Okay, so it's length 3. Okay, any questions about that? Okay, so scalars in R are just treated as vectors with one element. Okay, so they're pretty easy to deal with. Okay, so I have a equals 2. We saw this before, a similar example. Right, it is a vector. If you want to check certain data types, you can use a function called is.vector. You can check. And this is true for all the other data types, and it'll return a Boolean value whether it's true or not. Okay, and this is just going to say that the length of the vector is 1. Okay, because there's only one element. Okay. As I mentioned before, vector arithmetic, it's done element by element. So I just have some small vectors here just as an example. Okay, and so here we have v1 plus v2, v1 minus v2, similar notation that you would see in other circumstances. You can also use other functions, so you can get the square root of a vector, and it will do it element by element. Okay, you can enter these in. Okay, and it returns the vector with that operation operated on each element. Okay. Say you wanted to get maybe the dot product between two vectors. Now that's going to use some different matrix notation. And so rather than doing v1 asterisk, or that times, you have to use a percent sign in between, or surrounding your asterisk, because that's going to indicate that we're doing matrix operations, and so that returns the dot product. And that we'll see that also when we talk about matrices and doing matrix calculations using the percent signs. So it'll recognize the matrix arithmetic. Okay, you can also do comparisons between vectors. Okay, so this to check whether two elements, doing again element by element. So to check whether elements are equal, you use a double equal sign. Greater than or equal to, those are all very similar to what we see in other situations. Or if you want to just test it against a certain value, you could just enter in that value at the end. Okay. Any questions so far? Okay. The other, let me just go here, catch up. The other data structure is called factors. It's basically how R considers a categorical variable. Okay, so each possible value is called a level. And this is required for ANOVA or other statistical tests where you're using categorical data. Now usually when you call those statistical tests, it will automatically convert a vector into a factor in the test. But sometimes you might need to do it manually. So to create the factors, you can create it from a vector, if you have a vector of values, and you can just use the factor function with the vector name inside of it, and it will convert it to a vector, and convert it to a factor. So, for example, here is just a vector of 1s, 2s, and 3s. Okay, and if I want to convert it to a factor, I just use this factor notation. Okay, now if I look at F, it's recognizing it as a factor. It lists what the different levels are, 1, 2, 3. Okay. Or you can do it in one step. So here I just have the vector listed within the function, surrounding it by the factor function, and that'll automatically create a factor as well. Okay. Okay, so the next data structure is matrices. Okay, so it's a vector with dimensions essentially. Now it doesn't have to be columns and rows. You can't have more than 2 dimensions. The elements can be of any data type, but they have to be the same. Okay, so they all have to be all numeric or all string. And if you mix the data types, it will convert it to all string usually. Okay. You can take a vector and transform it into a matrix. So here I have a vector, it's just the 1 through 10, okay, in a sequence. And you can just change the dimensions of the vector to turn it into a matrix. So that's the DIM, it's changing the dimensions. And here I have a vector listing, I want it to be 5 rows and 2 columns, okay? So if I enter in that, and I come back to the console, if I look at V now, it's a vector, it's a matrix with 5 rows and 2 columns. Okay. You can start from scratch and use the matrix function and state how many rows and how many columns you want. That's just using the arguments n row and n columns. Okay, and then you can enter in the values individually. This is good if you have a really small matrix and it won't take long to enter. Okay, and you can just do it like that. Okay. So here's my matrix. 2 by 2 with the values input in individually. Okay, another way to do it, it's again using that vector notation. Okay, you can have it all in one vector, and you can state whether you want it to be, if you want the values to be entered in by the row, or you could say by the column, and just change this true to a false. Okay, so if you're entering it in, take the vectors and it does it by row first, or if you want to do it as it enters in by columns. Okay. So this is just a simple example with that. Let me just run these so I can show the examples of some matrix arithmetic. So here's A, same one as before, just with the other way to enter it. And then here's just another matrix B. Okay, by row equals true. Okay, so you can do the normal, functions with matrices. So say you want the transpose, it's just T, and then the name of your matrix in parentheses. Okay, so now I can get the transpose of my matrix right there. Okay, again, I said if you want to multiply 2 matrices, you have to surround the asterisk by percent signs to be able to recognize matrix multiplication. If you want element by element multiplication, you can just use an asterisk and it will do it that way. You have to be careful though if the matrices are of different sizes. It has a rule of recycling values of the smaller matrix into those calculations. And that's also true with vector addition or vector arithmetic. If you can add 2 vectors that are different sizes, the result will just be a vector of the longest length between the 2 vectors, and the vector with the smaller elements, those elements just get repeated to be able to handle the addition or the arithmetic into the other one. So if you're doing some coding that deals with vectors and you don't want that to happen, make sure you check to make sure your vectors are the same size, or else you get some surprising results. Okay?
Is there a justifiable application for that, or is this just laziness on the programmer's part?
That's a good question. That is how they handle scalars, though. So if I take a value and say I want to do 2 times my vector 1. Okay. So 2 is a vector with length 1. So it's going to recycle that value 3 times. So that is how it's being applied. Yes.
There's no great application.
Yeah. But that is one application of how they use it. Yeah.
So they can treat everything
as the same data type. Yeah. Okay. Inverse of a matrix, solve. Okay, and that'll give you the inverse. The determinant, DET, okay, gives me the determinant of my matrix. And then this diagonal function actually can do a couple different things depending on what you input into it. So if I just have this number 5, then it's going to return the identity matrix of a 5 by 5 matrix. Okay. Now, if I want a diagonal matrix that has a different value, so say 3, and I want it to be 5 by 5, you can have that 3 first, and it's going to return a 5 by 5 matrix with all elements 3 in the diagonal and zeros in every other location. Or if you want to return the diagonal elements of a matrix, so I have my matrix A already. Say I just want a vector of that matrix, okay? Then it returns a vector with my 4 and 1. So my matrix A was right. Well, this is the transpose, but it won't matter because I'm just looking at the diagonal elements. So it will return a vector of 4 and 1, which it does in a vector form. Okay. Any questions about matrices? You can also solve a system of equations using the solve function as well. And for example, say I have B is some vector. I'll just make up some numbers here, 1 and 3. And so say I have my matrix A, and I want to solve that systems of equations. You put your matrix in first, followed by the vector, and it will return the solution to that system. Okay.
So how can we get the general inverse for matrix?
A general inverse. So just like the inverse of a matrix?
Yeah.
Yeah, so that's using solve as well, and just entering in the matrix by itself, and it returns the inverse.
What about the general?
The generalized inverse, I'm not sure about that actually. Good question. I'd have to look that one up. Yeah, good question though. Okay. Any other questions? It's a good one. Okay, so that covers matrices. So one other data type, I won't spend a lot of time on this one, but I'll just mention it just so you're aware of it, is lists. It's an ordered collection of objects. What's nice about lists is that those objects don't have to be the same data type. So you can have a list that has a matrix, a vector, scalars, whatever you want, all contained in the same list. It can contain another list itself. Okay, and so to create a list, you just use the list function, and you can enter in whatever data objects you want. So in this case, mine are all vectors. In this case, some are just one-dimensional vectors. But you could also have another list or things like that. So here you can just list whatever you want in there. And here's my list L, and it lists each object in the list here. Now here they just happen to be all scalars, but you could have other objects, matrices, what have you. Okay, and then to reference a component of the list, you use double brackets for the list. So if I want the elements in the 4th component, I have L double brackets, and it returns that vector in that last data object. Okay. Okay, the last data structure I'm going to talk about are data frames, which is what you'll use most of the time, I'm guessing. It's essentially like a data set. If you're a statistician, that's how I would think of it. It's got a tabular data structure. It's made of vectors and factors. It can actually also have matrices. I've never actually used that in a data frame, but you can have a matrix within a data frame. So you can think of the vectors or the factors as the columns of the matrix of the data frame, and then one key component is that all the columns have to be the same length. Okay, so let me just show you a small example of data frames. So here I've just created a couple of different vectors or factors. They can be whatever you want if you want to, make up your own right now. So I just made up some people with some names, weight, things like that, just as a small example. Okay, so right now they're just all stored as vectors, and one is a factor. Okay, now I want to combine them all into one data frame. So I just use the function data.frame, and it will enter in all of the vectors that I want contained in that data frame, separated by commas. Okay. And here's my data frame. Okay, listing for each variable, right, the observation for each one. Okay. Let's see. So I'll just take this quick moment just to show of how you can import data rather than typing it in manually. If you have a large data set, that's ridiculous, right? So you can do importing for data files. It can import data from all different types of statistical software packages. The most simple one is just reading a table in, so a text file. You can use the function read.table. Now this is for Windows. I believe it's different for Macs. We had to adjust my code beforehand to make it work, but this is for Windows using the double backslash. And you can get the file location and the properties of your file if you're unsure where it is, to make sure you get the exact directory of where the file is located.
Something else you can do, at least on Macs, and I'm assuming Unix and Linux, is if you have your data file somewhere, you can drag that into your R console or R scripting window, and it will actually display the path that R would use on your machine. I don't know if that's true in Windows version or not.
I don't think that it is. Yeah.
So
Yeah.
Macs, Linux, Unix, step up.
Yeah. Thanks. Yeah.
As if there ever was any doubt.
So just some issues I've had when importing data files is with variable names that have spaces. Sometimes it imports it in very strange ways. Like it'll add in extra characters or awkward spaces, and you need to have the variable's name, correct when you're referencing them in your code. So if you have the ability to make sure that the variable names are short and without spaces, that would be great before you pull them into R. But you can always change the variable names once it's in R, though, to make it easier to reference. Okay. Some other arguments in the importing function is this header equals false. So if your data file doesn't have variable names on the first row, you can change that. And this SEP separator is just what's separating each data value. So it automatically assumes a space by default, but it could be a colon or a semicolon or a comma. And so you can add that in and say what's separating each element of the data. So here, this was just an example of data that I have. And so we adjusted it so it would be for Mac. And so here it's just a data set that I have. Okay, and so note in this one, the data file didn't have variable names on the top level, so I have header equals false. Okay, and this I just got from the UCI data mining repository. It's a data set on diabetes in the Pima Indian community. And so here's my data frame. I've saved it as diabetes, and I pulled it in this data file into a data frame. And one thing that I find useful is R can import data in strange ways sometimes. So there's a nice function to see whether it imported correctly, and that is this str function. Okay, it's checking the structure of your data frame. And so if you enter in this structure, it's saying I have 768 observations of one variable. In actuality, this should have 7 variables. Oh no, something went wrong. Okay, so actually what ended up happening is the data was separated by a comma, and it automatically assumed it was a space. Okay, so I went back in and I added in the separator with comma. Okay, and we didn't adjust the name of it. Sorry about that. This worked on my Windows. Okay, so let me rerun that. Okay, now I've pulled it in again. I look at the structure of my data frame. Oh, that looks so much better. So here, this structure tells you which variables you have. And now they're unnamed. They just automatically named them V1 through V9 because it didn't have names already built in. And it's saying what type of data it is. So this is integer, numeric, automatically pulling it in like that. Okay. Now here, I'm just going to use this a little bit later. So that's just me changing the names of a data frame. So if you want to change the names of your variables, you can just use names and then list a vector of the names in them. Okay. All right. The next thing I want to show y'all is some built-in data frames, data sets built into R, just so I can show a couple of examples of applications. So if you go to this, if you type in data, it's going to pull up a list of all of the data sets that are available when you download R. So you can reference all of these data sets. They're built in. Okay? And so I was using the CO2, that O is a capital O, not the number 0, which is a carbon dioxide data set that was built in. So that's what I was referencing. And so here, if you do help and then the data set, it pulls in, it gives you specifics about the data set, what the variables names, what the variables are, where the data set came from, and some background. You can also get, using this names and then the data frame inside, you can get what the variable names are in that data frame. I showed you the structure. The length gives you the number of columns in your data frame. Okay, so in this case, this data set, let me just pull up the structure of this one. Okay, and it also has some additional attribute information that was built into the data set that you may or may not have in your own data frame. Okay, so this says that there are 5 variables: plant, types, the different treatments, a concentration level of the carbon dioxide, and then this is the response variable uptake in this example. Okay, so it has 5 columns or 5 factors, or vectors. So you can get that with length. If you want the number of observations, you can use n row. Okay, and there's 84 observations. Okay, to reference the different columns in your data frame, you start with the name of your data frame. So in this case, we're using CO2. Okay, followed by a $sign, and then the name of the variable. So in this case, I want to just see, it will return a vector of, or a factor, depending on the data type of that column. So in this case, I just did plant, sorry. Thank you, Neil. So here I've just returned the first variable in the CO2 data set. Okay, so that you can use the $sign notation, or you can use a double brackets and put the name of the variable in quotes. Okay, either one will work. Okay, so this will return the exact same thing. Okay, if you're doing it, you can index it by the actual indexing number. Okay, so the way this is set up is the first element before the comma represents the rows, and the one after that represents the column. So if you want the first column with every single observation in the rows, you leave the first value blank, and then you put the comma, and then which column of data you would like. Okay, so this is going to return the exact same thing that I've done before, right? Instead of using the name of the variable, I've just used the index position of 1, because it's the first variable in the data frame. Okay, if I just want the first row of observations, but I want every single variable for that observation, you can enter in the row number, and then leaving the blank after the comma gives you every single column. Okay, so this is just the very first observation in the data set. Okay, if you want an exact element, you can use both. Okay, all right, so this is giving me the very first element in the first column. Okay, now a common mistake I make when referencing these is forgetting the commas, especially if I want just one whole column. Make sure you remember to put the comma into your reference inside the data frame. I make that mistake a lot, actually. So if you find there's something weird going on, that might be a quick check. Do I have the comma in the right spot, or if I've forgotten a comma? Okay. So this can be a handy function, the attach function. So what it does is it allows you to access all the variable names in a data frame directly without having to reference the name of your data frame first. So to avoid using that $sign notation to maybe shorten what you have to type. Now it can be useful, but it can also be a little dangerous if you have multiple data sets open, defined at the same time that have the same variable names. So it'll reference the most recent one. This is also can be problematic if you're writing code that other people will use. They might have the same issue, right? They might have other data sets or data frames defined that have similar variable names. So that's one thing to keep in mind. But if you're just dealing with one data frame, it can be kind of nice, shorten what you have to type in your code. So you just use attach and then the name of the data frame. Okay, and then if I use that search command just to show you. Okay, and now that CO2 data frame is now available, so I can reference the variable names in that data frame directly without having to reference it first. Okay, so say I just want to calculate the mean of one of the variables, I can use this function mean without using CO2 $sign uptake. I can just enter in uptake, one of the variable names, and it gives me the results. Okay, so just to shorten what you have to type. Right? You can also detach it if you want to not have that command. Okay, so I've detached it. Now if I try to do the same thing, I try to take the mean and I do uptake, I can't, and I haven't referenced CO2, right? There's an error. It doesn't recognize it because I haven't referenced where uptake is. I need to represent the object that it's in, the data frame. Okay, and so then I can fix that by adding the CO2 $sign. Okay, so that can be really handy, but again, be careful if you have a lot of data frames open. If they have the same variable names, you could get some surprising results in your analysis. Okay. Okay, now I talked about getting columns or rows indexing by a data frame, but say you want a subset of your data frame. In this notation, you don't necessarily have to have index values. You can use Boolean values too to get the index, or to get return values in your data frame. So say I only want in my CO2 data set those observations whose type was Quebec, okay, if you have multiple types. Okay, so I can create this Boolean vector. Okay, so if I look at select, it's just a vector of Boolean values, true and false, of where this condition is true. Okay, and say I only want the data where this is true. Then I can use the similar notation rather than having an individual value. So I only get the third row. I can just choose the ones where that condition is true. So if I enter in that, and I look at my new data set, right, I only have the values where Quebec. So that's nice if you just want to look at a subset of data. It can be kind of handy. If you can do it all in one step, you don't have to do it in 2 steps. You can do it all in one. So right here, right, this is creating my vector of Boolean values here. Okay, and in this example, I just switched it to Mississippi to just show the other way, since there were 2 different types. And again, make sure you have the comma there to make sure that you get all of the columns. Okay. And say you want additional conditions. So you have 2 conditions. Now I only want the ones that the plants come from Quebec and the treatment was chilled. Okay, then I can use this logical operator AND to be able to combine those into one. Okay, there are other logical commands you could use. I think I have them listed here. Yeah, or is just, I forget what that vertical line is called.
Pipe.
Yes, the pipe, and so that's the or command, the logical operator or, and is just the ampersand, greater than or equal to, less than or equal to, right? Similar notations, and then not equal is, you know, an exclamation point with an equal sign. Okay. Okay, so you have some additional data you want to add on to your data frame. Okay, you can create a new row or multiple rows. Store it as a data frame because it is going to have different types of vectors or factors, right? You want to save it as a data frame. You can enter in your values. Now you need to make sure that they have the same variable names as the data frame that you want to attach it to. If they have different variable names, it won't work. Okay, and then you use this rbind function. So data frame is my original data frame I had created before, and then I have comma new row, which adds the new row of data onto it. Okay, so let me just show you that. So now if I look at data frame now Susan's been added on into my data frame. Okay, you can also add a new column of data. So these 5 people took some sort of test, and they you can just store it as a vector since you're just adding it on. Now to deal with missing values, R uses NA, capital NA. If it's lowercase, it'll convert it to a string. So make sure it's capital. So you can store that, and then instead of rbind, you use cbind, and it's going to add that column at the end. And for this, you want to make sure that the ordering is the same as you had originally, or else you want to make sure the observations are matched up with the right data. Okay. Okay. And so now here's my data frame, and now test has been added on to the end. Okay. I showed how you can change the names of a data frame. Okay, so you can just do call names and put the data frame in parentheses, and then here you can list what you want your new names to be. Okay, this is useful if if R has imported in the data is strange and the vector names, the variable names were strange to begin with, they have weird spaces or weird characters, you can change the names so they're easier to reference when you're doing your analysis. Okay. If you want to edit values in a data frame, that can be a little tricky because it doesn't automatically have, like a data table like you'd see in JMP or Minitab, something like that. You can manually edit it, but there's no undo button on this. So once you do it, it pulls up this data window, and you can change the values if you want to. Now, as a statistician, I would probably not recommend doing that unless you're 100% sure that it was a mistake. But if you are, you can change it, and it will change the value in your data frame, at least in the R file. If it's an original text file, I mean, that would stay the same. But within your analysis within R, it would change that value. But be careful because there isn't an undo. You'd have to rerun the code, right, to get back to where you started from. Okay.
That makes it sound like you're saying that it changes in DF as well.
Yes, it would change in DF. It would. Okay. Yeah. If I had imported this from another source, from like a text file, yeah, right, it wouldn't change the text file, right? But the data frame, yes.
Why would you assign it to another variable?
So I assign
DF changes DF automatically.
It does. So if I change DF, like if I just enter in, let me just come out of here for a second. Oops. If I just did edit DF.
You've got to close the edit window.
Oh, where did it go?
So you just go up to the top window.
Yeah.
So go back to our console window. And then here.
Thank you. Sorry, I don't use Macs. Okay, let me close this. So if I just did edit data frame, okay, I can edit it, right? And so say I made a mistake, right, and I changed the wrong value, it's going to change data frame, but what if you forgot what that original value was, right? You can't go back, right? So the reason I saved it as a temporary file was that so it wouldn't change data frame then, it would just save it into my temporary data frame.
But that seems to be the opposite of what you said when you said temp is edit of DF.
Oh, okay. Let me rephrase. Okay, so the reason why I assigned it a new variable, it wouldn't change data frame within that unless it was just by itself. So if I had edit data frame only, okay, it would change data frame. Okay, and I recommend not doing it that way in case you make a mistake. Okay, so that's why I had it as temp equals. So it's saving as a separate variable. So if I made a mistake, data frame is not changed, and I can go back to it.
Yeah.
Yeah. Sorry. Yeah. Sorry about that. Yeah. So does that make sense? Yeah. So I usually don't use that, but if you know there's a mistake, you can go and fix it, but just be careful. Yeah. Okay.
So I've got a basic question.
Yeah, no problem.
Sorry, we've all been so quiet listening.
No problem.
So in the data editor, I just added a couple columns and I could add stuff there too. So if
you could.
A really small data set,
yeah.
Is data editor like a way that you would maybe create small data sets?
You could. I actually haven't used it before that much. I discovered it while I was doing some research on this, and I'm like, this is kind of cool. But no, you can. So if you have a small data set and you just want to do like a quick example, yeah, you can use that. Absolutely. Yeah.
Okay.
Yeah. For longer, and the other nice thing about the data editor is that you don't automatically see your data when you create it. Like you import a data file, well that's not, usually, if you're in some other software, you can actually see the data table and get kind of an idea. And this allows you to do that as well. If you just want to scan the data and just do a quick overview, that's another way that you can use it as well, just to be able to look at your data. Okay?
Thank you.
Sure. Oh, good question. So these are a couple of other examples. I have these in the slides. I'd kind of like to get to some of the statistical tests. This is just some other neat little tricks that you can use. And if you want the slides, I'd be happy to give them to you. But you can remove missing values. Now, again, as a statistician, you may not want to do this because it will remove the entire row that has a missing value in it. But that is a way that you can handle missing values. Within different functions, you can have it ignore rows with missing values and just compute, for example, the mean of the values that don't have missing. You can do that too without having to remove the entire row. But I just wanted to show that that was a possibility. If you want to remove a column, you can do a subset function, and in select you can list the variables that you want, or if you want all but one of them, you can use this minus and then the name of the variable that you don't want. Okay. You can also merge files by a common variable. So for example, I had that short little one that was by name. Okay, and so in that case, you can join additional columns, which I showed how to do. But if you have other ones and you have the name, so in case they're in different orders, you can use the data.frame function, and in this last one, enter name, and it's going. I'm sorry. That's creating the data frame. You use the merge function, and so here's my one data frame, here's the second data frame, and this by is the common variable that they have in common. So you can do it that way as well. And then adding in this all.y equals true ensures that in case there are discrepancies, so it's maybe one person or one observation is in one data set but not the other, and you want everything to be in there no matter whether there'd be missing values, this allows that to happen, all.y equals true. Okay. I do want to mention these apply functions before we get to some statistical tests. The apply functions are useful so you can avoid doing loops in R. So actually doing, for example, a for loop is fairly inefficient within R. And the way the apply functions work is they allow you to do the same type of function across multiple rows or multiple types of blocks of data. So here's this data set is trees. It's built into R. I picked it because it had all numeric columns just to make it easy. So say I want to get the mean of every single variable. I use this sapply function. Okay, this first value is the name of the data frame, trees. It's built into R. And then the second argument is the function that I want. And mean is built into R as well. So if I want the mean of all of the functions, all of the variables in my data frame, okay, I stored it as it's going to return it as a vector. That's what the sapply, that's what S stands for. It's returning it as a vector. Okay, if I look at my results, okay, it's returning, it has three variables, in this case, girth, height, and volume, and it's returning the mean of each variable. Okay, so that's nice if you want to do some quick analysis on a whole bunch of variables in one data frame. Okay, this version, using lapply, it returns the results as a list. So I mentioned lists earlier, so they can have different types of results in there. So it's giving us the same information, but it's the structure of the result is a little bit different. So in this case, it was just a vector. In this case, it's a list. Okay, so the reason you would choose one or the other would probably depend on what your analysis was or what you were doing. Okay, but you don't have to do just the mean. You could do, now I don't, as long as it makes logical sense in the analysis, you could test the mean and just do a t-test on all of them. So here it's giving a t-test on all of the values. So it's similar notation. Here's my data frame, and here's my function, t.test. Okay. Or you can define your own user function. Like you can create a function, and so again you use sapply. Okay. List where your data is, the data frame. Okay. If you're creating your own function, right, you start with function, so it'll recognize that you're doing a function. And the X is just what you're using it as, how you call it. So what it's going to do is it's going to take each column within your data frame into that function. Okay, and here it's going to take each element in the column, and I just define this, I'm just standardizing it, right? Just X minus the mean divided by the standard deviation, and it's going to do that for all of the values within this data frame. Okay, so for girth, it's doing it by column, so it's taken each element in this girth and standardized it. Okay. Let's see. Okay, if you want some more information on apply, there's also a link on our bloggers that I found that could give you an example, and I actually found this example from there, or a similar example. So here is an example of a matrix, and here, don't worry too much about this. I'm just creating a matrix with some random normal data with different means. This is just to show. So here is this should have a mean of 0, 5, and 10. Okay, and now I want to calculate the mean over the matrix. So here I can use the apply function is different from sapply. It uses matrices, right? You can use it for matrices. The other ones are for data frames or lists. So here's the name of my matrix. The 2 represents that I wanted to do it by columns instead of by rows. and then here is the function. Okay, so if you put a 1 here, you could do it by rows. So if you had like longitudinal data, right, you could do something like that as well to be able to do that. Or you can define your own function, right? I have function x and then x squared. Okay, so just to show those. All right, so it's calculating the mean of my matrix and that. Okay, I didn't pull in my list. Okay. So now I'm just going to go over a couple of basic statistical tests if you guys have some time. I know we started a little bit late, but I just wanted to show these if you have some time. So you can do some basic, here let me just pull this in just so I have my example. So here's just my data frame that I've been playing around with. Okay, so basic functions, you can get the mean, right, of any of your variable, right? So here I just have mean function, and then I've referenced the variable that I want to get the arithmetic mean of. Okay, in test, it had a missing value, right? Susan didn't have a value for this test, so it returns a value of NA, right? It doesn't exist. So to avoid that, you can add this argument na.rm equals true, which will remove the missing values from the calculation. So it will just calculate it over the observations that have values. Okay, so you can calculate that, right? It doesn't eliminate it from the data frame, right? It just doesn't count it when it's doing the calculations. Yeah.
So by default, R does not ignore missing data.
Exactly. Yeah. By default, it does not ignore the missing data. So if there are missing values in your data, but you just want to get the mean, you can do that by adding in this argument. Okay. You can get the correlation between two quantitative variables, right? Just using the core function, COR. Okay. T-tests. Pretty simple command, t.test. Okay, this is just what if you're doing a one sample t-test, right? You just enter in the vector that has your variables in it. You can change the option. So mu equals changes. The default is that you're testing that the mean is 0. So mu equals, well, you can change what your hypothesized mean is. The default confidence level, of course, is 0.95. So this is giving the confidence level, conf.level. level. Right, you can change it to whatever you want. And the alternative, by default, it's a two-sided test. So you can change it to greater or less. And you just put that in quotations. Okay. If you have a two-sample t-test, there are a couple ways you can do it, depending on how your data is set up. So one, if you have your two samples in two different vectors, they're not in the same data frame, they're completely separate, you can do t.test and just put it in commas. If you had two different variables, okay? If you have them divided by, if you have, in this example, you had uptake and it was divided by different treatments. So you have your factor. You can use this notation where you have your response variable, okay, tilde, okay, and then whatever your treatment level is or factor, your categorical variable, how you can distinguish between the two different types. Okay, so let me just show that. And it's doing a two-sample t-test. And again, you can use the same arguments to change whether it's two-sided, one-sided, things like that. Okay, you can do the Pearson correlation test. This is core.test. Okay, a normality test. The one built into R is the Shapiro-Wilk test. Okay, which is just Shapiro.test, and it gives you your normality test. Okay, I mentioned packages earlier. So there is a package that has additional test for normality. So for example, the Anderson-Darling test. So there's a couple ways you can install packages through code, or there is it's probably a little bit different in Mac, but you can do it through the GUI menus as well. So here's the code to do. I won't do it now because sometimes it takes a little bit of time to actually install it depending on the system, but you just can do install.packages and list the package that you want. And then you need to load it to be able to reference it. Okay, and then if you want to get the details about that package, you can do this library and then call the help function and be able to get the different procedures or functions that are available in that package. Okay. This is to deal with categorical variables. So if you just want some contingency tables, right? You can use the table function. I didn't define this data frame, so that's why it's not working, since I skipped that part, but this does work. And so that's how you can just get a contingency table. And to get a chi-square test of independence, you can put summary around it to get additional information. Okay, and let me just finish up with some linear regression, because this is using the linear models tool, and then I'll wrap up. Okay. So with linear, say you want to do a simple linear regression, so I'm going to use the trees data set, and I want to be able to predict volume by the girth. Okay, so linear models, what it does is it creates a different data structure that contains all the information from your linear regression model. So usually what you want to do is you want to store the results of that analysis into its own variable so you can reference it later. So here you use your response variable, and this tilde is how you're going to set up the model. So here I'm just doing a simple linear regression, and I have one variable girth, comma, and then this represents where the data is stored, the data frame. So data equals trees. I'm using that trees data set. Okay, so if I run this by itself, okay, and I look at results, wow, it doesn't give very much information by default, right? All it's telling me is what the coefficients in the regression model are. All right, well, that's not so useful. So what you do instead to get all the details, summary, results, and there's some more information. It gives you information on the residuals of the linear regression. It gives you the t-value, the t-test for each coefficient. And if you want the ANOVA table specifically, right, you can do ANOVA to get the results. So by default, it doesn't give you all of the information, right? You have to just add in a little bit extra to be able to get to it all. Okay. If you want confidence intervals, right, on your coefficients, right, conf int, right, and there they are. Okay, for the intercept and for the other term in the model. Okay. Right, this is pretty much how it works also if you have multiple regression. If you have additional variables, right, you can enter them individually, and this is going to give just the main effects, right, so no interactions if you just use the plus sign. Okay, so this just gives where my two predictors, right, so no interaction between these. Okay. To add an interaction plus the lower order terms, you use the asterisk sign. So this automatically does, it takes the two-way interaction in all lower order terms. Okay? So here's my girth, height, and the interaction between girth and height. Now if you had more than two factors, it's distributive. So if I had three factors and I did, you know, x1 times x2 times x3, it's going to take the three-factor interaction plus all the lower order terms. So that includes all the two-way interactions and the main effects. Okay. If you want to specifically list which interactions you want, you can use a colon between the two variables. That's how they represent interactions. And if you want to do a model that doesn't have the intercept, it's a little bit strange notation. You have your variables, and then you can do a -1. And so that's going to do your linear model without the intercept. Okay. You could also say +0. They both work the same way. +0 or -1 is how they deal with no intercepts. Okay. To do an analysis of variance, you can also use the linear models tool. Similar, you know, here's your response variable, here's your treatments, right, and the location of your data. There's also a function AOV, analysis of variance, or one-way.test. Okay, these only perform one-way ANOVA. So, okay. And since we've gone over time, I think I will leave it at that. You can also do some non-parametric tests. And the regression with interactions. There's some basic plotting that can be a subject since we're over time. I can get you these slides so you can reference it, and we can do some more advanced plotting in another session as well. I just want to wrap up with some of the common mistakes that I make in hopes that it'll help you later on. One is forgetting to use double equal signs in logical statements. So if I want to test if two things are equal, just to make sure you have those two equal signs so you're not assigning a variable. I mentioned this before, missing those commas. I do that all the time. If you mistype a command in the console window, let me just give an example of that.
You get an error message.
Yes, you do. So
Unless it's valid in some other way.
Exactly, exactly. So like, for example, this in the Mac, it automatically adds in those parentheses. In a Windows, it does not. So that's why I always make mistakes, is forgetting a parentheses or a bracket. So say I want to do a t-test on that CO2 uptake. Okay, but I forgot that other parentheses. It has that plus sign there. Okay, so that means it's expecting something else. Like the function isn't complete, it's missing something. If you missed a parenthesis, say that you had a whole bunch of parentheses and you have it in the wrong spot, right, your function's going to be totally messed up, right? So the easiest way to get out of that is to hit escape. And it gives you back to that caret, and that means it's expecting data. So that is a common thing.
On Macs, Linux, and Unix, if you press the up arrow, you will get
Yes.
The previous one.
previous
Yes.
ones that work in Windows.
It does. Good point. And you can go back as far as you want as well. Okay. So those are common mistakes I make. I forget those. And to get out of that, the plus sign means that it's expecting something more. And so if you just need to start over, hit escape, and you can get back to that. Another thing is dealing with brackets versus parentheses. So functions usually deal with parentheses. Lists have brackets. So just being able to recall which ones deal with parentheses. Other ones is capitalizing function names. So sometimes all of their function names are usually lowercase. So if you've accidentally capitalized something, okay, that's something to keep in mind of. And then order of operations. So this is one thing that I do a lot. So say you want to do a loop, okay, and so say I have some value of n that could maybe say it's like to 10. And I want the loop, I won't do the loop now, but say you want to sequence it from 1 to n minus 1. Okay, so in R, colons take precedence over other arithmetic. So say I want to do this loop or a sequence from 1 to n minus 1. Okay, what I really wanted to go is 1 to 9, right? That's what I think I wanted to do. Okay, but that's not what R does, right? It does the colon first, so it's doing 1 to 10, and then it's subtracting 1 from that vector. So if you're doing, this comes up a lot if you're doing functions, so make sure you put parentheses around the n minus 1 to make sure you get what you expect it to do.
Actually, parentheses when you don't need it is a good idea too.
Absolutely, better safe than sorry.
If you don't know right away what the order of precedence is, put them in.
And so I discovered this. There is a site on R on their syntax on what takes the order of operations from highest to lowest. And so you can check this out too if you ever have some doubts about what comes first, what it's doing first in the operations. Okay, so with that, I'll leave it there. I use this R cookbook in my data set there. So if y'all have any questions, I'm happy to answer them if I can. I'm glad you guys were able to come. I hope it was helpful, at least a little bit. And when we have if you have any particular topics that you'd like to see in R that are more advanced, let us know and we can try to have that be the topic of one of our future talks.
Quick question.
Yeah.
So all of this stuff that I've been typing in the console while I've been listening to you, how can I save it for later reference?
You can save the workspace, and I can show you how to do that in a second. Yeah,
Okay, save
yeah,
workspace,
yeah,
got it, okay.
yeah. That's one reason why I recommend using the script window, because it makes it really easy to save things later on. I mean, saving in the workspace works as well, but I really like dealing with script windows, yeah, as well. Either one, yeah. Okay, well, thank y'all so much. Have a good weekend. Thanks, Neil.
No problem.
Hold it.